You are listening to a universe of possibilities. This is Astronomy FM.
Coming up next, an Astronomy.fm original program. It's time for York Universe, a co-production of the Observatory of York University, Toronto, and the Voice of Astronomy. AFM Radio, AFM Radio, AFM Radio, AFM Radio.
Hello and welcome to York Universe, the astronomy and astrophysics program written and presented by the students, faculty, alumni, and friends of York University. I'll be one of your hosts this evening. This is Julie Tomei, and I am joined by Dr. Elena Hyde. Hi.
Hello, hello.
We are broadcasting live from the Allan Carswell Observatory located at York University in Toronto, Ontario, Canada. This is Science Night in Canada, where the lineup is all Canadian, starting with ourselves, York Universe, then on to Western World, Quirks and Quarks, and Science for the People. York Universe broadcasts every Monday night at 9 p.m. local Toronto time, and that is a Tuesday morning at 1 a.m. in Universal Coordinated Time. York Universe production works in concert with our online public viewing program, which is run by the Observatory team, which runs between the hours of 9 and 10 local Toronto time. Head over to www.yorku.ca/science/observatory and follow the links to OPV, that's online public viewing, and join the chat. Our broadcast is powered by and in partnership with Astronomy.fm, the voice of astronomy. For any questions or comments you have, or past shows, or if you have any suggestions for future topics, send us an email at observe@yorku.ca. You can always connect with us on Twitter, where our handle is York Observatory, or at York Observatory. On Instagram, our handle is at YorkU Observatory. And on Facebook, search for Allan Carswell OBS. All of our programs are free, but we won't say no to donations. So if you are so inclined, head over to our website and click on the donation button. We'll be monitoring the chat room for questions and to post content. The weather in Toronto is increasingly cloudy, so I'm assuming it's going to be, at least towards the end, archival images. I'm not sure if they've got the scope open tonight.
It's pretty cloudy out. I don't think we'll be able to open. We do have the sky camera working again, but unfortunately we're a little short on people tonight, so it's going to be archival images. We'll work on getting that sky camera set up so that it's easier to do more of that in the future. But unfortunately, yes, the clouds once again are ruling the Toronto skies.
Hey, despite a little bit of sun today, at least up where I am, the evening calls for some flurries. So happy first day of spring, everyone!
Yes, it is the equinox, so I suppose we should be saying, happy equinox. Although technically, I think the official time was 5:24 Eastern Time precisely for the equinox. That's Monday, March 20th, 2023, 5:24 Eastern Time in Toronto, Ontario, Canada.
Well, I never get that precise with it. It's today. And happy Nowruz to those who celebrate.
Absolutely. And actually, if you are interested in astronomy and equinoxes, the Nowruz use of the Iranian solar Hijri calendar is really interesting astronomically. So this is actually a really fun one to look up for folks. If you're not familiar with Iranian astronomy, their solar calendar is one of the most accurate in use anywhere in the world today. So it's got a lot of interesting stuff going on, not just, of course, equinox, but also calendars, holidays, and we can look forward to the days getting longer. So there's always that.
Huzzah! I always look forward to the days getting longer after a time change.
Oh, well, The time change is its own problem. That has nothing to do with astronomy. That's entirely human-created problem.
Oh, yeah. You finally get to the point in the year where it's like, oh, good, I get up and it's sunny outside. And then boom, darkness.
Yeah. There's really no reason for that at all in any kind of logical, sensical system. Unfortunately, we don't live in one of those, so we still have it whacking us twice a year.
Yes, logic doesn't live here.
No, not in that sense, no. But at least for the solstice, astronomically, everything is proceeding according to plan. The sun has crossed the celestial equator, and we are now moving towards those longer days and shorter nights, which is a little sad astronomically, but maybe those shorter nights will also be clearer nights, which would definitely help us out.
Well, yes, this is just it, right? Like, I'm sure if we looked up the stats for 2023, the number of days where we saw that bright orb in the sky, I think it's called the sun?
The UFO. There's a whole thing about unidentified flying objects over Toronto and balloons. We're just looking for the sun right now. So
honestly, like, can you count it on more than one hand?
The days where the sun has come out clearly recently?
Yes. Since the new year.
Oh, since the new year, I can think of at least 5.
I'm not convinced it's more than 5, though. It has been cloudy.
Yes, it has.
Here's hoping for some clear nights.
Exactly. Clear nights, more observing, and lots of fun stuff to see, of course, this year with lots of meteor showers, lots of really good meteor showers supposedly coming up. Anywho, March equinox, very fun. Hope you all are having a good one and in slightly clearer skies than us.
All right. Well, let's jump into our This Week in Space and Astronomy History. Why don't you start us off, Elena?
Absolutely. So, of course, this week in Space and Astronomy History, we can go anywhere in time that we want, but we aim for a certain day, as in close to the current day. So we're at 20th of March for the equinox, and just as a little call out, the equinox is almost always on the 19th, 20th, or 21st. So all of our This Week in Space and Astronomy histories would have also been close to the equinoxes in their respective years. So going back to 2001, March 23rd, we had a pretty fun event happening, which was the Mir, and this is what they call it, re-entry. So it's not called a crash if you do it on purpose. So this is sometimes called re-entry, sometimes called deorbiting. So this was the end of the mission for the Mir space station, the Russian space station. So if you are not familiar with the space station, the Mir, which means peace or world in Russian, was a space station that operated in low Earth orbit from 1986 all the way until its deorbiting in 2001. This was a really interesting sort of first for humanity, having this modular space station assembled in orbit from 1986 to 1996. It was larger than anything that had come before, and it was definitely the largest artificial satellite in orbit. So it's been succeeded by the International Space Station, which is what we have now. But its orbit was, decaying, and as its orbit decayed, they had to decide what they were going to do, and they decided to deorbit, or basically let it crash. While it was up there, this was quite a long time, 1986 to 2001. It had the, at the time, first sort of continuous habitation in space. It was a long-term research space station, and it held the record for the longest continuous human presence in space at 3,644 days. That was actually surpassed in 2010 over on the International Space Station. Excuse me. So all kinds of records and successes research-wise happened up on the space station. But one of the things that's really interesting are the advances that they made in solar technology, actually. The photovoltaic arrays attached to the modules providing power to the space station. We can sort of credit a lot of their development of solar panel technology with what we've seen currently in sort of the modern solar power era. So there have been so many amazing mirror stories, and of course, despite having many issues over the years, it was extremely long lasting and a great success. When it was decided that it would not necessarily crash, but have a controlled deorbit maneuver, it was sort of secured its place in history as the first modular space station. So this was enabled semi-permanent human habitation. So in theory, you could stay there forever as long as people kept bringing you food, and you could live there for a very, very long time. So you had generations of astronauts and cosmonauts up there. We had a lot of cooperation between the Soviet Union and America and other countries. And during its sort of human occupancy years, they had hundreds of cosmonauts going on there, and a lot of research in actually how humans respond and interact in weightless environments as well. So very, very, very successful mission. And it's pretty interesting that they were able to get it to go so long. Although, of course, it did eventually enter the atmosphere and was destroyed. The International Space Station program that overtook Mir, in a way, is a little bit responsible for its eventual demise. And some of us kind of wonder why wouldn't they just keep Mir and attach the International Space Station to that and make it even bigger? But a lot of the very old technology was kind of at the end of its lifetime, air recirculation and all that good stuff. So they did have to sort of prioritize whether or not they were going to keep Mir or go to ISS, and the ISS kind of won. So at the time when it was being brought back down to Earth, of course, people were a bit worried about it because this is far too large to burn up in Earth's atmosphere. There were a lot of concerns about the large pieces of Mir, like docking assemblies, the gyrodynes and the structures, whether or not they could survive re-entry and crash. And when the debris was falling, New Zealand actually issued international warnings to ships and aircrafts in the South Pacific, saying, watch out. And eventually it did land in the South Pacific Ocean, sort of spread around a fairly wide area. So lots of articles around 2001, Mir destroyed in fiery descent, and all kinds of things, which avoid saying that they crashed it into Earth. So this approximate date back all the way in the olden times of 2001, which doesn't seem that long to me, but that's only because I'm getting old.
I know, right?
I was like, 2001, that wasn't that long ago, was it? Oh, wait.
The millennium turned just like yesterday.
That was like 5 years ago, max.
Yeah, max. It's interesting because I've never, I don't know. I mean, I know of Mir, obviously. I've talked about Mir. I've never gone and really taken a look at pictures of Mir. It's nice.
Yeah,
the insides they really show its age, though.
The older systems, you can see why they decided that they're like, we'd rather invest in a whole new system. Because a lot of those components were, from the 80s, and at some point it's better to just go with the new the new International Space Station instead.
I'm
And I think they say that it ended up traveling something like 2.2 billion miles over its lifetime going around and around Earth, which I totally believe.
looking at a photo of the interior of the docking node,
Oh,
and,
wow,
and
yes.
it is just a mess of like hatches and hoses and cables. And I'm like, how do you even, wow.
Yeah, well, and when I look at old photos from especially Muir in its last couple of years, I am reminded of our own observatory and the dome replacement that we've done.
Yes, that's it exactly. And it has the same feel as like this for anyone listening who's like been to the Allan Carswell Observatory and who's been in the dome with the big 60 centimeter telescope that is
Yep.
like massive, and it just feels like something from the 60s.
Oh yeah.
Like I know this is the space station that went up in the 80s, but it has this sort of like it's just this pale green color. It just feels like something out of like a 1960s like sci-fi movie. It's fantastic.
Oh yeah, yeah. And it's nice that they were able to keep it running for so long. Um, but one of the advantages that we do have here on Earth is that it's a little easier for us to keep our historical stuff. So they had to crash this back, and I mean, by the time it
Oh,
hit the ocean, it was pretty well and truly destroyed.
oh yeah, absolutely.
But fortunately, our observatory, we can actually go ahead and save things like the actual 60 centimeter telescope. We don't need to crash it into the ocean. We can just retrofit it, and it'll be okay.
Oh yeah, yeah. All right. Definitely an amazing project and feat of technology there.
Yeah, so I was talking about something going down. I think you've got something going up.
I do. So we are going to March 25th, 2000, and the launch of the IMAGE mission. So IMAGE is an acronym that stood for Imager for Magnetopause to Aurora Global Exploration. This spacecraft was also known as Explorer 78 or MIDEX-1. It was a NASA medium explorer mission to study the global response to Earth's magnetosphere, to changes in solar wind, and was part of NASA's Sun-Earth Connections program. It was meant to be a 2-year mission, but it wound up lasting 6 years before it unexpectedly ceased operations in December 2005, which was during its extended mission. In January 2018, an amateur satellite tracker found it, and it was transmitting some signals. There were some attempts made to communicate with it, with, as I understand, some level of success, but the signal was lost again in August of that year. The payload included energetic neutral atom imagers, which use helium, hydrogen, and oxygen in the exosphere to form images and determine properties of parent ions. It had UV imagers. It had a radioplasma imager, which used pulses of radio waves to image the entire volume of Earth's magnetic field. It produced loads of data, and those data have been used in over 400 research articles.
That's a lot.
That is a lot.
Well, and of course, watching the magnetic field is just such interesting stuff anyways. there's not just, watching aurora, which are actually kicking up quite well right now. Maybe not today, but those of you who've been watching for your space weather warnings, you might have seen more and more about aurora getting farther and farther south, maybe even visible from Toronto. And that, of course, activity is really interesting to watch because that's our sun interacting with our magnetic field, which we're very, very glad to have. Deflecting those highly charged energetic particles.
Yes, the aurora are definitely a happy secondary effect to the protection that we get.
Yeah, well, it's nice to see. It's nice to see proof that it's still out there protecting us, because of course, the magnetic field, especially, fleeing from Canada as it is, which if you haven't heard before, until the early 1990s, the magnetic North Pole was in Canada. However, it has been running away from us at about a rate of 9 miles a year or 15 kilometers a year. So it's now off in the ocean. It's left Canada and is drifting rather rapidly, which lots of geoscientists love to debate about. Who knows? It might even affect some of the those interesting aurora watches. But this, I think, it's a little bit too bad they couldn't get more out of their their probe, especially if it's out there trying to study Earth's magnetosphere. I suppose it lasting until 2005 isn't so bad, but we've gotten used to expecting so much from our from our NASA missions.
Hey, 3 times the expected mission is pretty good.
It is, and of course, as you say, they did get 400 research articles out of it, so not so bad. Something to think about next time you see an aurora watch going in for I don't know, northern Toronto or something.
Yes.
Northern Ontario, I should say.
Well,
if we're really lucky, northern Toronto.
It's happened. I've seen it.
In Toronto?
Mm-hmm.
When was this?
When I was still at York. So probably sometime around the time this thing launched. Actually, I think it might have been 2001 or 2002.
Yeah. Excellent. So, you would have been near another solar maximum. Well,
I have the photographic proof.
I'm still hoping to get lucky out at Killarney Park at some point.
Yes.
Anywho, magnetic fields, lots of fun, and endlessly entertaining.
Yes. Well, from I don't know how to transition this. Yeah, no, I've got no segue here.
Magnetic fields. We can just talk about magnetic fields.
Yeah. Okay.
So speaking of magnetic fields,
from Earth magnetic fields to a magnetic field elsewhere. How's that?
Yes.
Okay.
Magnetic field far, far away, of dubious, dubious quality. So I'll go back quite a ways. So just to throw everyone completely off, we'll leave the 2000s far, far behind, and we'll go to March 25th, 1655, when Huygens discovered Titan. So Titan is an amazing object, a moon of Saturn, the largest moon of Saturn, and the second largest natural satellite in the whole solar system. It is it's the only moon known to have a real dense atmosphere. It's I think probably, arguably, and I mean you could argue with Europa, arguably the most planet-like moon out there in the solar system. It has an actual atmosphere made of gases. It has an actual surface, and it has liquid on its surface. Notice I did not say water; I said liquid. It was discovered in 1655 by the Dutch astronomer Christian Huygens, and this discovery was pretty interesting at the time, of course. Back in 1655, there was a lot of things going on. You had sort of, interesting debates in the laws of physics, and astronomy was just sort of, I suppose, getting a little bit of a renaissance. But discovery of objects orbiting other things in space was a nice confirmation of course, a heliocentric solar system, showing that Earth is in fact not the center again. And Huygens did a lot of other things around this time. He's very accomplished as an astronomer, observing the planet Mercury transiting over the sun, using at the time, modern telescopes, and helping to advance sort of telescope technology and usage to what we would call sort of more of a, I suppose, modern astronomy, rather than sort of the old-fashioned by eye or without telescope aid, shall I say. So Huygens had a huge amount of other things he's done, and his work with clocks and models is something to watch for. But the system of Saturn was one thing that he's made immense progress on. So he didn't just find Titan, he was actually watching Saturn quite closely. Of course, Saturn's rings are something that are fairly easy to see, even with a small telescope. But Huygens made a whole report on the system of Saturn, so Systema Saturnium, and it's a wonderful document. But you do have to read Latin if you get a copy. So he not only did a report on the planet, he did relative distances of the planets from the sun. He introduced a concept of the micrometer. He used angular diameters and measured angular diameters of planets, which was really allowing the telescope to be used as an instrument rather than just, I found a thing, but I'm going to measure a thing. So making real measurements, geometrical and otherwise, with a telescope. He did also get into some, arguments with Galileo, apparently, but it was pretty exciting time all around, not to be outshone by the moon itself. So Titan, having this really interesting property of an atmosphere, wasn't discovered until quite a bit later, when telescopes had improved a lot, and we didn't actually get any good pictures of Titan until we had sort of the first flybys of Saturn. And the exploration of Titan was, of course, the primary goal of the Cassini-Huygens mission. So Cassini-Huygens spacecraft in 2004 got the first direct images of Titan's surface, and we found that its atmosphere was nitrogen and methane and hydrogen. It's got lots of interesting things around hydrocarbons. It's really interesting because I've not read a lot about its own magnetic field, but Titan spends 95% of its time within Saturn's magnetosphere, which actually means that Titan gets shielding from the solar radiation from Saturn. It's inside its magnetosphere. So the magnetic field of Saturn is large enough that it extends out, and Titan gets some help from that, some shielding. So it's atmosphere reacts with sunlight, kind of producing this kind of thick orange color that you might have seen. There are a few true color images. It's sort of it's kind of a not a bright orange, but sort of a very, very light, pale, orangey yellow, I would describe it as. But incredibly thick atmosphere. And of course, on the surface, the first images coming back from the actual lander, lakes and riverbeds and channel systems. Of course, the lakes were hydrocarbon fluid, we think. And there have been proposals since then to send, sailing ships and actually explore the surface. From the JWST, people have been looking at Titan and looking at things like cloud patterns moving around, and it's been really, really interesting to see it go. There's just so many interesting things about this moon. I think we could make a whole episode about it, but one of the great things to remember about Titan is that it's thought that perhaps early Earth might have had some compositional similarities to something like Titan, as inhospitable as its atmosphere may sound. So there's a big interest in investigating it more, and it's just a shame it's so far away because, of course, out at Saturn, it is well and truly takes quite a while to get there, shall I say. So I think that's probably all I should say about Titan for now, but it was discovered March 25th, all the way back in 1655, and we're just waiting to see what kind of new discoveries we can make about it, even right now with JWST and other spacecraft.
Yes. Oh, such a fascinating moon.
Yeah, I think we could spend a whole episode just talking about Titan, but we should probably move on to something else if we're going to do more of these.
Probably. We'll take a moment now to let you know that you are listening to York Universe, broadcasting live from the Allan Carswell Observatory, located at York University in Toronto, Ontario, Canada. If you are so inclined and have not yet joined the online public viewing, head over to yorku.ca/science/observatory and follow the OPV links to join that and join the chat over there. And you are listening to Dr. Elena Hyde and Julie Tomei, that is me. And we are just about to wrap up our This Week in Space and Astronomy History. We are jumping to March 26, 2009 with the launch of Soyuz TMA-14. This was a flight to the ISS with two members of Expedition 19, Roscosmos astronaut Gennady Padalka and NASA astronaut Michael Barrett, as well as Hungarian-American spaceflight participant Charles Simonyi on his second and last spaceflight. Simonyi is a software architect who started and led Microsoft's applications group and built the first versions of Office. So,
very talented.
the thing that most people use. He was born in Budapest, where his father was a professor of electrical engineering, and he became He became interested in computing while working part-time as a night watchman at a computer lab during secondary school. And he learned to code from one of the lab's engineers. At 17, he left Hungary on a short-term visa, and he never came back, fulfilling his desire to, quote, get out of Hungary, go to the West, and be free, end quote. He worked in Denmark for a little bit, and then he moved to the US and went to university and worked at Xerox on one of the first PCs before moving to Microsoft and doing all the fun stuff of developing Office. And and became interested in wanting to go to space. And so his first flight to the ISS was in 2007, and this 2009 flight was his second. And the crew patch for this mission incorporated the artwork of then 12-year-old Anna Chibiskova of Moscow, who won first place in a contest that was run by Roscosmos for children aged 6 to 15. And Anna, along with 3 other children whose submissions won honorable mentions, were invited to the launch.
Very fun.
Yeah. And I invite people to go take a look at the crew patch. Anna's artwork is of like 2 hands holding up the Earth, and it's got the Russian flag and the American flag.
Well, you heard it here first, folks. Learn to code. You never know where it'll take you.
Right?
But I always recommend to all of our students to learn at least the Python programming language. Mm-hmm. It's just so valuable, even more so today than back in 2000 and whatever that was.
Well, I mean, 2009 was when he went to space. He learned to code sometime, I think, in the 60s. I'd have to go back and look. But yeah, learn to code. You could end up able to pay your way to space twice over.
And it's so much easier now. You've got, we've got GitHub, what's it called? Copilot and and Python coding notebooks. It's
Hour of Code, YouTube videos.
Oh yeah. It's definitely gotten to the point where it's really, really interesting to see how advanced you can get. Just right off the bat, I'm amazed at some of the things that people can do now with first year undergrad coding, and I'm just like, oh, if only I had known that during my PhD. It would have been so much easier. The kids now don't know how good they had it. No, but learn to code, everybody. It's a good idea.
Yeah. Well, it is, in the last few years have been incorporated into both the math and science curricula in Ontario.
Oh, good.
So, yeah. Just this year in the science, and I think 2 or 3 years ago in the math. So they're starting to get that. The school kids, at least, are starting to get their doses of coding. It's the teachers who are freaking out because, like, what do I do? What do I do? How?
Well, I keep meaning to post my Learn Python in 1 hour notebook. So once I get that up, I'll put a link to it on there.
I would check that out because that is one that I have not learned.
Well, I talk as if I
know so much coding. I learned Turing in high school and at York.
See, Fortran?
Fortran. That's what I know.
Fortran.
And I taught myself some HTML, which is not really.
Oh, it counts. You can do scripting.
Does it? Okay.
Yeah, totally.
All right.
Totally. You don't even know how many pieces of interactives on our website are just online Google Sheets basked in HTML sauce.
Beautiful.
If it works, it works.
All I can say is when I was in Teachers College and we went in one day and the prof said, okay, you're all going to get into groups and you're going to write down the instructions on how to make a peanut butter and honey sandwich. My group was me and a bunch of people who had just decided to switch careers because the dot-com bubble had just burst. Yeah, my group was the only one that had wound up with a sandwich because she followed the instructions to a T. It's like, yeah, I know how to give good instructions step by step.
Yeah. Well, that's all it really needs, because computers will never do anything other than what you tell them. And like the thing is, no matter how smart it is or what the machine is, it's only using machine logic, right? And machine logic, it's great at like counting or counting fancy or counting to very high numbers. But it's very you know, it, they're inherently not able to do what humans can do yet. So don't worry, folks. But yes, it is interesting because, of course, if he was learning in the 60s, the coding would have been very much based around basic machine logic. And that is historically very interesting. And that's probably also a different episode of York
Yes.
Universe. Because when you get into how information is transferred through bits and bytes, it's absolutely fascinating that we've gotten where we are.
All right. So far this evening, we've decided to have an episode on Titan and an episode on logic gates.
Yes. Yes, absolutely.
All right. I believe we have a couple of reminders.
Yes, I did have a couple of reminders I wanted to send off to everybody, just in case you hadn't heard. The Allan Carswell Observatory is running once again our very fabulous, super amazing Astronomer in Residence program. That's right, 2023 Astronomer in Residence program happening again with Killarney Provincial Park all summer of 2023. So this is an amazing opportunity to go out to a park. Julie can tell you all about it.
Oh my God, it was the best week of my summer last year.
It's really, really fun, but you do have to be able to run the telescopes and give astronomy tours. There are 2 telescopes on site, and the astronomer in residence goes out to the park and gets a very nice lodge room to stay in, and almost everybody elects for the lodge. Well, only two people did elect to get a campground instead. You stay out there, you give astronomy talks, you operate the telescope, you do some solar observing, do some evening observing. Some folks went down to the lake and did star hopping. It's really, really fun, and it is a certified dark sky site. So if you're going out to Killarney Provincial Park this summer, watch out for the Astronomer in Residence program. If you are an astronomer and thinking about applying, it is open. So applications are open right now. That's right at this very minute. So the air schedule starts off in May and runs all the way through to mid-October. So you can sign up for any weeks that are available. You can go for 1, 2, or 3 weeks, and you do have to do the application and get approved to go out there, but it's absolutely amazing. So if you know an astronomer or you are an astronomer, make sure to tell them about this. It's on our website, so in case you didn't get the link before, yorku.ca/science/observatory, and then just go to Astronomer in Residence program, and that will take you directly to the AIR site. You'll see all about the program, the park, how to apply, all that good stuff. So very, very, very fun. Totally recommended. It's happening for only the second time ever. So I'm really looking forward to this summer. I think it'll be really good. And I think with the uptick in solar activity, maybe this will be the summer I'll finally see an aurora.
Nice. Yeah, it was amazing. Dark skies, a telescope
So
right
dark
outside
skies.
the door. People were so appreciative. It was my first time back behind the telescope with people, I think, since I'd left York, because all my other astronomy, no, I'd done like star parties and stuff when I was at Science North, but yeah, it was so lovely. And you do your like astronomy stuff in the evening and the few like solar observing things, and then the rest of the time is yours to enjoy the park, do the hikes, go to the beach, read a book.
Yeah, put your feet in the water. It's
Do
really,
all the other
really.
programs they offer.
Oh yeah, and the artist in residence program also going to be very fun. Anywho, that's okay. So we have
Yeah.
another episode to do. But
Yes.
if you want to check out the blogs from last year or follow along with blogs from this year once they start, both last year's blogs and this year's blogs are on the website. So you can go to the Air blog and you can see what Julie did last year. And then once May rolls around, we'll be able to share with you all what our new astronomer in residences are up to. So that's announcement number one. Announcement number two is a little bit smaller, but more current. So this week is March, and on March 25th of this actual year, 2023, it is the spring open house at York University. This is a big open house for all of York University, but especially the science departments. So if you are thinking about doing an open house, please be advised that on March 25th from 9 a.m. to 2 p.m., the York University open house will include the Allan and Carswell Observatory. So we're actually doing tours through the spring open house. So if you're signed up for that, you can come on the observatory tours. They're going all day as the open house happens. And we'll also have a booth down there where we can talk to you about the telescopes and tell you all about the new domes. And I'll tell anyone who will want to listen about our new Perseus port. It's really, really cool. So that's all happening March 25th. So that's our other little reminder. And that takes us away from the reminders for this week. And I think we actually have time to cover some news items.
Yes. Well, I always make sure we have time to cover at least one.
So I think we should do the Didymos one because that is Diformos Didymos is one of my favorite news stories. I just love how people have been following this system and the DART mission. It's just been super, super fun. So let's do that one first and then see what we have for.
Sounds good. So listeners will no doubt remember the DART mission that purposefully smashed into asteroid Didymos's moon Dimorphos last fall.
Again, not an accident.
Nope. That was on purpose. That was the whole point of the mission. Can we make this thing go somewhere else by smashing into it? So the spacecraft did take some data on the system before that event, and the results are pretty interesting. The data suggests that Didymos is throwing material out into space. And as we send more missions to study asteroids, we're learning that the idea of asteroids as like a solid hunk of rock might be correct for some, but there's just as many that are loose collections of rubble that are weakly held together by gravity. Another prime example of this is Bennu, the asteroid that OSIRIS-REx took a sample of in 2020, when the craft sank nearly 2 meters into the surface when that sample was taken. But anyways, back to Didymos. So we now know that it spins quite fast, once every 2 hours and 16 minutes, making it an asteroid that is, quote, on the edge of stability, according to a recent paper preprint. And at the equator, this means that rocks and dust can lift off and levitate or even move into orbit. So the bits can levitate and then land, and sometimes it'll like do that several times, and sometimes those bits will end up landing at latitudes from which they can't lift off anymore because it's just not moving fast enough at that point. Some, as I mentioned, go off into orbit. Some are likely actually go off far enough that they get deposited onto the moon, Dimorphos, and some can escape the system altogether. The larger bits tend to levitate for longer because the dust is pushed back down to the surface by the solar radiation pressure on the daytime side. And so these conclusions are somewhat preliminary because the work is based on best estimates of the asteroid's size, composition, and shape. But there is another mission headed there in 2027, and this is ESA's HERA mission. So the HERA mission should be able to like corroborate the estimates and make the conclusions a little bit more solid. 97% of the particles that lift off the surface land again within 5 hours. And this is work that's important because as we're sending more spacecraft to study these similar asteroids, this is a phenomenon that mission planners will have to take into account in order to avoid possible damage to future missions.
Absolutely. And, especially if it's, we're going to have to make a good call on whether it is like, Bennu and, well, these asteroids or like a solid object. Because if it's literally almost spinning itself apart, you've got so much debris coming off, and that's going to be high velocity debris too. So you wouldn't want any spacecraft carrying humans to come anywhere near that. Especially if you're thinking like asteroid mining and doing things on a surface. Like you need a surface to land on if you're going to do stuff on the surface. So this is hugely important, and it's so interesting too because like if you did want to just, I don't know, collect a bunch of rock, if it's already basically falling apart, you don't actually have to do that much to get some off of it, but you 100% would never want to do that with like, humans. You're looking at robotic missions, which is what they've been doing, so that's good.
Yeah. Oh, for sure. But yeah, and you definitely want to make sure that you haven't like spent all your time and money and effort and you get out there and then like, oh no, this thing smashed our spacecraft, baby.
Yeah, well, and if it is like this type of object, that's going to be how common these are is going to really determine the future of a whole potential space industry, because people have been sitting there drooling over asteroid mining for ages. But you have, so much momentum being transferred by these fragments. If you impact one of these and you eject a whole bunch of more fragments, you've just made that whole area very unsafe to be in. And if you are trying to redirect, as they were with this actual experiment, like see if I could push this asteroid or whatever, we want to call it, low density asteroid, you could push it out of its orbit. But if it's going to dissolve and create a debris cloud, or if it's going to be pushable, right? And so this one, they did actually see it change its orbit. But as I recall, they got more debris actually landing on the other object as well. So that while they changed the orbit, they've also increased the amount of debris in that area by a fairly large amount. And I think the visible trail was about 10,000 kilometers long, but I don't know what it's thought to have expanded out to. So in its whole orbit, it's going to be spewing debris for as long as that is going on, right? So you've now created a debris field of some size by doing this. There's the picture back in 2022 of that 10,000 kilometer long dust trail, which, as you say, was some of it's been pushed by sun's radiation pressure, but now you literally have a debris trail. So it's really interesting because it's a whole problem that we didn't even think about before this mission, and now it's this might be one of the determining factors for all kinds of asteroid missions going forward.
So interesting. It's funny because I always thought of like, yeah, whatever, asteroids, just rocks in space.
But
Now I'm
there's
like,
so many different, yeah.
yeah, now I'm like, tell me more. Send more things to asteroids.
So many different kinds of rockets in space, and there's animations that have been taken from ground-based telescopes, and I would just like to say, for the sake of the observatory, we did try to get Didymos Diformos, and we were crowded out for a week. So we weren't able to capture images of the debris cloud from the Allan at Carswell Observatory, but other telescopes that were in clearer skies did actually capture the debris plume coming off in various stages. The sort of push of high velocity debris coming out from the object, and the head-on impact of this spacecraft did impart quite a lot of energy into the system, and they thought it would reduce the orbital velocity, and it did, bringing it closer. So sorry, I shouldn't say Diformos. It's Dimorphos, I think. I've been saying going closer to Didymos, getting its orbital velocity sort of reduced, and getting a shorter orbital period, and measuring where that orbital period settles is something they're still actually working on. So if you measure the impact being greater, in different cases, the ejecta coming out, what I've read is that it's actually in some cases thought to increase the effect, which means if you have ejecta, you get more momentum transfer in some cases. So how much exact material was ejected into space and how much more effective this was in terms of changing the orbit. That's also important for people to know, because you don't want to accidentally change something's orbit by way too much and push it into Earth instead of pushing it where you wanted it to go.
No.
It does seem like the sort of thing that might happen. So I am personally very, very glad they did this on an asteroid that was nice and far away.
Yes.
And well outside of any possible Earth contact. So despite our conversation here tonight, don't worry, folks. None of this will reach Earth at all, despite spreading out hugely.
Excellent. Do you think you can give us our little update in 2 minutes?
Oh my gosh. Well, just the last little tiny update is that there has been a recent release on the Europa Clipper. So this is a little bit of a different mission. Quick 2-minute summary. The Europa Clipper is again, satellite mission, but it's actually going to explore Jupiter's moon Europa. So I was sort of tongue-in-cheek about Titan, which is the most planet-like moon, Europa or Titan. Well, Europa has a lot of water, and the water is liquid, and it has an ocean. We know it has an ocean. We've seen it seeping up from the cracks on the surface. So Europa has been a very, very, very high priority target for astronomers for a long time. But we don't know whether its underground ocean is habitable. It's around Jupiter, and Jupiter has a lot of radiation. So because we just haven't explored Jupiter that well, we've sent some satellites, but there's so much more to learn. The Europa Clipper is a mission that's been proposed to launch in 2024, next year. And so they've actually released an update saying that they still think they're going to launch in October of 2024. It will have a series of flybys while in orbit around Jupiter, and keep flying by Europa, looking at Europa's ice crust, studying the subsurface ocean underneath. So if you are interested in water in the solar system, Europa is a very, very very, very hot destination. It's, got a frozen crust, but very, very fun. So I'll go ahead and say, please read up on it. It looks like it's actually going to launch next year, and I'll end there.
Amazing. Thank you for that update. All right, folks, you've been listening to York Universe, the astronomy and astrophysics program written and presented by the students, faculty, alumni, and friends of York University. Your hosts this evening have been Dr. Elena Hyde and myself, Julie Tomei. Stay tuned because it's Astronomy Night in Canada. Coming up next is Quirks and Quarks, Western World, and Science for the People. Thanks for tuning in. Clear skies and have a good night.
Good night, everyone.
Program from AFM Radio, the broadcast service of Astronomy.fm. This program has been released under Creative Commons license. Please contact us for details. You may find more of our AFM original programs on our website. It's really easy to find us. We are Astronomy.fm. You may also find us in the iTunes radio listings near the top of the News Talk section, and also as an iTunes podcast selection. We'd love to hear your comments. Please email us at radio@astronomy.fm. Thanks so much for being part of the voice of astronomy around the world and across the known universe. This is Astronomy.fm Radio.